Hello everyone, Mr. Schultz here, and we're doing Integrated 2 3-4, which is side-side-side and side-angle-side similarity. So we have already learned about angle-angle similarity. That is when three angles, so let's write that down, three angles need to be congruent for the two triangles to be similar. Cool. If all the angles are congruent, then the triangles are similar. Excellent. Now we've also learned about angle-angle similarity. So let's write that in. Angle-angle similarity. Now we do not need three angles now, we only need two. So if any two corresponding angles are congruent, then the two triangles are similar. Alright, now we're going to talk about the next ones. We have side-side-side similarity, or SSS similarity. So if the corresponding side lengths of two triangles are proportional, so let's write that in, proportional, then the two triangles are similar. Let's write that in. All right, well, the example of this. Okay, well, if, for example, let's put T and B, because we're going to write this out. If AB, so now we are going to tell you like they match up. So we take the largest side. So let's say AB is the largest side. The red is the largest side. Over ZY is equal to CA over YX, which would be equal to the blue sides, CB over ZX. So in this situation, what we have to do is we have to make sure we put the large over the large, the middle over the middle, and the small over small, or it won't work out. So if all those are equal to each other, then hey, guess what? The two triangles are similar. Let's go on. Number 4, side-angle-side similarity. If the lengths of, so I'm going to read this fast. If the lengths of two sides of one triangle are proportional to the lengths of two corresponding sides of another triangle, and the included angles are congruent, then the triangles are similar. Wow, that's a bit of a mouthful. But what this is saying is, hey, look, we're going to take two triangles, and we're going to take one side, the angle between, and the other side, and we're going to see, hey, if let's see which is the small side. Small. This is small. This is small. If 12 over 8 is equal to 16 over 24, or no, 24 over 16, and the angle in between are congruent, so angle B is congruent to angle F, well then triangle, let's go with this, BAC is going to be similar to triangle FDE. Well, we should probably prove this a little bit. Divide by 4, I get 3/4. Divide by 8, I get 3/4. Okay, so yes, the two sides are proportional. All right, so let's review this, and we'll see this when we're talking about congruent triangles. Go ahead and hold your fingers like that. 2 fingers. Give me some deuces. So it's always going to be side, angle, side. It's going to be the angle in between the two sides. If they are proportional, if these two are proportional, and the angle in between is congruent, then bada bing, bada boom, the triangles are similar. All right, let's go on to some example problems. All right, determine whether each pair of triangles are similar and explain your reasoning. Okay, well, let's see. All right, so it looks like, all right, let's pretend we can put 4 and we can put 5. Are these the values? No. But if we were to write this out, we would say, hey, look, this is 4 over 5, and that's equal to 4 over 5. Well, then yeah. So we know that the two sides. So put up your fingers, give me some deuces, and congratulations, bada bing, bada boom. These are similar, but we have to say why. So I'm going to say triangle RST is going to be similar to, let's say it's triangle WSX, because of side angle side similarity, because there's two sides, one angle. All right, let's do number 2. All right, it looks like this one is going to have to be side, side, side because there's no angles. Well, let's see if it is. I'm going to take the large sides, 9, 9, 12, 12. So let's put 9 over 12 is equal to 9 over 12, which is equal to 6 over 8. Let's see if they are proportional. Okay, well, I don't need to do these, but let's do this one. I'm going to divide by 2, divide by 2. I get 3 over 4. If I divide by 3, I get 3 over 4. I don't need to, they're the same, so I don't need to do it again. Therefore, well, first off, let's say this is going to be ACB. Triangle ACB is going to be similar to triangle, where was I? PRQ. Why? Because of side, side, side similarity. The sides are proportional, therefore, side, side, side similarity states that they are similar. Let's go on. Example 2. Identify the similar triangles, then find the value for x. Okay, well, let's do it. All right. Now, you might be thinking, hey, we're going to use side, angle, side because we have two sides and an angle. But look there. There's an x. We don't have that value, so we can't use side, angle, side. Now, if I have this right here, though, this is what we call a vertical angle. These are congruent. And now, we understand this is going to be angle-angle similarity. With angle-angle similarity, we understand that these two triangles are similar because we have two angles that are congruent. All right, well, now we have to just figure out which ones are which. Well, it looks like angle K matches up with, so let's see, we're going to have angle H, triangle HIJ is going to be similar to triangle KLJ. All right, well, now we just need to find the value of x. All right, so we can find the reverse of it. So if we understand that they're now similar, we understand that the sides are proportional. So I know this one's going to be bigger. So I can do the comparison of this. We have 8 over 4 is equal to 10 over x. So I'm going to try to do some magic math here. I'm like 8 times, nope. 4 times, can't do it. Well, I don't like this variable on the bottom, but I'm going to simplify this. 8 divided by 4 is going to give me 2. So I'm going to write this out. 2 is equal to 10 over x. Now, I don't need to do the cross product or anything. What I'm going to do is I'm going to multiply by x on both sides. So I'm going to times x on both sides. 2 times x is 2x is equal to 10. Now, I know it's going to equal 5 because 2 times 5, but let's divide by 2 on both sides, and I get 5 units is equal to x. All right, let's go on. All right, so we're on number 7 right here. So we want to prove that these are going to be congruent. Now, it looks like we only have one angle, so we have to prove it using side, angle, side. And remember, we're looking at these. Give me to throw up some deuces. Let's see. Large side, not the hypotenuse, so large. So we're going to do this. We're going to say the large side over the large side is equal to the large side over 3. let's see if that's true. Alright, well, I don't really like having the fraction, so I'm going to multiply by something. And in fact, I'm going to multiply by 4 on this side. I'm going to multiply by 3 on this side. If I would do 3 times 4, and 3 times 4 is here, then if I multiply 4 times this, then 3 times 9 should be the same answer. Let's see if that's the case. Alright, I was just going to do this without showing the work, but I just got to do this on this one. So if I do 3 times 9, that's 27. 3 times 4, 12. 3 times 4, 12. Now I'm going to do 4 times 6.75. That's 6 3/4. So 4 times 6 is 24. And 4 times 3/4 would give me 3. And by golly, look at that. These two are proportional. Therefore, I can literally state that, hey, look, triangle, and let's start with RST. Triangle RST is going to be similar to triangle UVW. Now, why did I pick that? Okay, well, I'm going to go from the 90-degree past the longest of the two sides and then go around. I'm going to start at the 90-degree and I'm going to go past the longest side and then all the way around. That's pretty much what I did. That's one of the tricks to figure out, all right, I don't want to mix these up. I'm going to find a way and figure this out. But wait, guys, we still need to find out what is x. All right, so in all actuality, we could have done the Pythagorean theorem to figure out what that answer is, but they want us to do this way. So what we're going to do is let's do the following. We're going to say, hey, 9 over 4 will equal x over 5. Okay, solve for x. Well, we don't have to do cross product. We don't have to do that, okay? We just have to get x by itself. So I'm going to multiply by 5 on both sides. That's going to cancel this out. After that, I get 45 divided by 4 is equal to x. Well, if I divide that out, I get 11 with 1/4 remaining. Technically 11 and 1/4 units, but let's not go into that can of worms. Alright guys, looks like we still have a few more minutes, so let's keep going. So this will be our last example, and then the following 2 questions will be yours to complete. So sailing. The 2 sailboats shown are participating in a regatta. If the sails are similar, what is the value of x? Okay, well, what makes this difference? It's just a real world example. That's the only thing difference on this. Everything else was exactly the same. All right, and the numbers are a little off. All right, well, they're saying these are similar. Okay, well, I don't need to prove they're similar because it's saying they're similar. So I know that it's going to be 264 over 220. Now it's going to be x over this. So we just have to do the work and do it. That's it. So I'm going to create my proportion. 264 inches divided by 220 inches will equal x inches over 168.5 inches. Now I can just go through and get rid of all my inches because I don't really need them because we're solving for x and it looks like x is just a number. Alright, well, now I just have to do the math. If I divide 264 by 4, I could simplify it. So I'm going to divide by 4 on top and divide by 4 on the bottom. 264 divided by 4 is 66. And 220 divided by 4, let me use the calculator. Alright, it says it's going to be 55. Well, looking at this, I know I can divide by 11 now. So if I divide by 11, I get 6 over 5. Yeah, that's pretty cool. Like simplifying all the way to that. Do we need to do that? No, I was just messing around right now. So that's equal to x over 168.5. Now, I can multiply by this number and get rid of it because we're trying to solve for x. And who's with x? It's 168.5. He's dividing, so I'm going to multiply by 165 on both sides. Now, once I do that, let me get my handy-dandy calculator. I get 1,011 divided by 5. And when I divide by 5, I get 202.5 is equal to x. Not 5, 2. I read my calculator. 202.2. All right, well, could we have done this better? I mean, not really. I mean, I could have used a calculator and done 264 times 168.5 is equal to x and divide that by 220. And would that have given me the exact same answer? Yeah, but that's why one of these problems, it's like, whatever. If you're using that tool, great. If not, why aren't you using that tool? You should be using a calculator. All right, so let's go over the next two problems. So for 18, you're going to create a triangle that is similar and explain how you know it's similar. So you could be using angle, the angle postulate. You could be using side, or you could be using side, angle, side. Just make sure that you explain why. And then the final one is, hey, actually, I don't want you to do this. So I'm gonna go like this and cover it up. You don't have to do this one because that's going to be our warm up tomorrow. So you just have one question left. Draw a triangle and explain how you know it's similar. It's your choice. Angle, side, or side. All right, guys. Thank you for listening, and I hope you guys have a wonderful day. Bye.